We just finished talking about neutrons. So now let's go ahead and take a look at electrons. Okay, so for electrons, we need to know that electrons are going to orbit the nucleus in an electron cloud, but more specifically, they orbit the nucleus in energy levels. And each energy level is going to be a specific distance from the nucleus. And for example, like each energy level is going to get farther and farther and farther from the nucleus. Okay, so for example, the first energy level can only hold a maximum of 2 electrons. And then the second energy level can only hold a maximum of 8 electrons. Now, there are higher energy levels that go even farther than that. But the most important two to know about are the first two. So I definitely would memorize those. Okay, then the outermost energy level, whatever that happens to be, is going to be the valence shell and is going to contain the valence electrons. Yeah, the electrons in the outermost energy level are supposed to be the valence electrons. Now, the way to calculate the valence electrons, like how are we supposed to know what the valence electrons are? So first of all, we could calculate it by hand. So that's actually what I did with the carbon. So let me show you how to calculate the valence electrons or find the valence electrons by hand. Okay, so before we find the valence electrons, there's a few things that we need to know actually. So we would need to know that electrons fill from lowest energy level to highest energy level. So they fill from low to high. So you could kind of think of them as like lazy. They really don't like to go to a higher energy level unless they absolutely have to. Okay, so, and then we also need to know that electrons completely fill one energy level before going to the next. So you have to completely fill it up before you go to the next one. Okay, let me pick an element. Let's say we have something like magnesium, Mg. Okay, so magnesium has an atomic number of 12. So that means that it has 12 protons. And then automatically, it's very important that you understand that the electrons automatically equal the protons. Whatever the protons are, automatically the electrons are the same. So that's how you know how many electrons that there are, is it just however many protons there are. That's it. Okay, now, so basically these 12 electrons are going to need a place to like quote unquote sit. We need to figure out where are these electrons going to be sitting. Okay, so like I said, they fill from low to high. So the first energy level can only hold a maximum of 2. So it's almost like there's only a maximum of 2 chairs on the first energy level. So only 2 electrons can sit here. So after those first 2 electrons on the first energy level, we still have 10 left that need a place to sit. So now that the first energy level is full, now the electrons, they don't have any other choice but to go to the second level. Okay, so now the second energy level can hold a maximum of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 more electrons have found a place to sit. So now there's only 2 left. Well, the second energy level is full. So now these last 2 electrons, they don't have any other choice but to sit on this last energy level, third energy level, like that. So these were on the second energy level, and now these last 2 are on the third energy level. And now there's no more left. So you can see that the outermost energy level happens to be this third energy level. And the number of electrons in this third energy level is 2. So this energy level, because it's the outer one, that is called the valence shell, and it contains the valence electrons. There are 2. So that means that there's 2 valence electrons. Okay. Okay, now there actually is a way, a faster way to figure out the number of valence electrons, but it requires that we know the periodic table. Okay, so first we need to know that the periodic table has rows that are called periods, and then the columns are called groups, or in other words, families. And then we also need to know that there are 3 different kinds of elements on the periodic table. There's metals, metalloids, and nonmetals. So metals are more on the left-hand side of the periodic table. Most of the periodic table is metals. So everything that's colored right now is a metal. So you can see that there's a lot. There's a lot of metals. And then some of the properties of metals. Metals tend to be good conductors of heat and electricity. They also are shiny. They are also ductile and malleable. So ductile means that you can stretch it into a wire. And then malleable means bendable. Okay. Now, and all that should somewhat make sense for metals. Okay, the nonmetals are more on the right-hand side of the periodic table. And they tend to have the opposite properties of metals. So they are poor conductors of heat and electricity. They're only semi-ductile or bleh. They're poor conductors of heat and electricity, and then they're dull and brittle. And that's it. Okay. And then, like I said, the nonmetals are more on the right-hand side of the periodic table. So everything that's colored there, that is that's a nonmetal. Okay, now, oh, hydrogen is the only exception. Hydrogen, even though it's on the left-hand side of the periodic table, it's still considered a nonmetal. So even though it's with the metals, it's weird. Hydrogen sometimes acts like a metal, even though it's a nonmetal. Okay, now let's take a look at metalloids. So the metalloids, that's what I was getting ready to say, that those are like semiconductors of heat and electricity, and they're semi-ductile and semi-malleable. So in other words, sometimes they can conduct heat and electricity really well. Sometimes they can't. Sometimes they can be stretched and made into a wire really easily. Sometimes they can't. So the semi-metals / metalloids, they form a staircase line on the periodic table. Okay. Oops. Let me see. Let's move on now to the shortcut for the valence electrons. So to quickly figure out the number of valence electrons, we can usually look at the group number, or in other words, the column number on the periodic table. Okay, so for example, everyone in group 1 only has one valence electron. Everybody in group 2, or in other words, column 2, has two valence electrons. Now, the elements in the middle, they are a little bit special because those are transition metals. And transition metals, their number of valence electrons is hard to figure out from the periodic table. So the shortcut doesn't work for them. The shortcut does not work for them. So we just skip over them. And then the pattern picks up in group 13, which is also sometimes labeled as 3A. And that will have 3 valence electrons. Everyone in group 14 has 4 valence electrons. Group 15 has 5, group 16 has 6, 17 has 7, and then 18 has A. Okay. Now we do need to know that there is something special about the number 8 for most atoms. Okay, so most atoms want 8 valence electrons. That is their goal. That is when they are the most stable. And that desire to have 8 valence electrons is called the octet rule. So definitely be familiar with that term in case you ever see that term octet rule. You know what it means. It means the desire to have 8 valence electrons. Now the elements in group 18, they already have 8 valence electrons. And so because they already have 8 valence electrons, they actually tend to not chemically react with other elements. And that inability to react with other elements is called inert. So inert means non-reactive. Okay. So you also need to be familiar with that term, the term inert and what it means. Okay, next we also need to know that everyone in group 1, or well, actually, let me back up. Some of the groups, and remember a group is a column. Some of the groups have special names. So for example, everyone in group 1 let's see, everyone in group 1 is called an alkali metal. And everyone in group 2 is called an alkaline earth metal. Everyone in group 17 is called a halogen. And then everyone in group 18 is a noble gas. Okay, and then yeah, I think that's it from this page. But anyway, my point is that this is how you can quickly determine how many valence electrons that there are in an element is just by looking at the group number. Okay, now let's go back and let's take a look at why are we even talking about the valence electrons? What makes them so special and important? Okay, so the reason why valence electrons are so important to talk about is because they determine the chemical properties of an atom. They basically can determine who binds with who and when and how and why. And then also because all atoms of the same group have the same number of valence electrons, and because valence electrons determine the chemical properties of an atom, then that means that all atoms of the same group are going to have the same chemical properties. Okay, so for example, if a question was to say which two elements are alike in reactivity, we would need to pick two elements that are in the same group. Okay, now let's talk about one reason why understanding valence electrons is important is because it's important to understanding about ions. So an ion is an atom that has lost or gained electrons. Because keep in mind that all atoms want to get to 8 valence electrons. And that's their goal. So in order to get to 8, that means that they might have to lose electrons or gain electrons to get to 8. Okay, so once an atom loses or gains electrons, first of all, you can't even call it an atom anymore. You now have to call it an ion. And so once you know that you have an ion, then the number of protons and electrons will not be the same. That's very important. For example, if the question is asking you about the electrons, like to find the number of electrons for an ion, you're going to need to know that it's not automatically going to be the same number anymore. Okay. There's two different kinds of ions. There's cations, and then there are anions. Okay, so cations are supposed to be positively charged. They're positively charged ions, and they form from atoms that have lost electrons. Now, if that's confusing, like, wait a minute, why would it be positive if it's losing? We need to keep in mind, actually, you know what? We'll come back to that in a second. Hold on. So, like I said, for now, just mostly know that cations are positively charged ions, and they form from atoms that have lost electrons. And you can try remember that the T in cat looks like a little plus sign. That's how you can remember that cations are positively charged. Okay, then for anions, anions are negatively charged ions, and they form from atoms that have gained electrons. Okay, now let's talk about why. Like I said, because I think it's confusing to people why it's cations are positive if they're losing electrons. But we need to keep in mind that electrons are negative. And so you could kind of think about it like with people. Like if you lose negativity, then you become a more positive person. And so when the atom loses negatively charged electrons, it will also become positively charged. That's how it becomes positively charged, is from losing. Okay, now with the anions, anions are negatively charged. So it's, again, if we think about it like with people, if you gain negativity, you just become more negative. And so when an atom gains negatively charged electrons, it will also become negatively charged. Okay. Now, let's talk about, okay, but how do we know if it's going to lose or gain? Like, how are we supposed to know if it's going to lose electrons or gain electrons? So this is one reason why talking about the valence electrons beforehand was so important, is that's how we figure it out. Is by looking at the valence electrons. The valence electrons are going to determine if the atom is going to lose or if it's going to gain. So for example, let's take a look at metals. So metals are more on the left-hand side of the periodic table. And that means that most of them are going to tend to have less than 4 valence electrons. So for example, like everyone in group 1 is going to have 1 valence electron. Everyone in group 2 is going to have 2 valence electrons. Everyone in group 13 is going to have 3 valence electrons. Actually, we'll just stop at group 13. Because group 14 is weird. They have a mixture of metals and nonmetals. But anyway, so the metals, since they only have 1, 2, or 3 valence electrons, that is so far away from getting to 8 that they just give up. Because think about how difficult it would be to try to find 7 more valence electrons or 6 more valence electrons. That's going to be almost impossible. So they think, you know what, just forget it. I'm never going to get to 8. I might as well just give up what I have. And so when they give up and when they lose the valence electrons that they have, they become positively charged cations. Okay. So right, metals lose their valence electrons and they tend to become positively charged cations. Okay, then nonmetals. Nonmetals are more on the right-hand side of the periodic table. And they tend to have more than 4 valence electrons. Okay, so for example, everyone in group 15 has 5 valence electrons. Everyone in group 16 has 6 valence electrons. Everyone in group 17 has 7 valence electrons. And so because all of the nonmetals are very, very close to the goal of 8, there is no way that they're giving up their valence electrons. They are way too close to that magical, happy, perfect goal of 8. So they're not going to want to lose, they want to gain. And so when they gain those electrons, valence electrons, they become negatively charged anions. Okay, and then so right, this is kind of the bottom line, is that metals lose and become positively charged cations. And then the nonmetals gain and then become negatively charged anions. Okay. All right, now let's go ahead and start talking about the different kinds of chemical bonds. So first of all, we actually need to know that there's two different kinds of chemical bonds. There's intermolecular and then there's intramolecular. So for the intermolecular bonds, those are between molecules. Intermolecular bonds are between molecules. And then the intramolecular bonds are inside of a molecule. So the typical bonds that we normally think of, the ionic and covalent, those are actually intramolecular bonds, not the intermolecular bonds. So we need to be very careful to know which type of bond that the TEAS is talking about or asking about. Because like I said, there's a big difference between these inter versus the intramolecular bonds. Okay, so let's go ahead and still take a look at the intramolecular bonds. Okay, so the intramolecular bonds are the ionic and the covalent. Okay, so the ionic bonds, we need to know that in an ionic bond, there is a transfer of electrons. So basically, one atom is losing and then one atom is gaining. Now, the way that you can just look at a substance and just know if it's ionic or covalent is actually paying attention to the types of elements that are there. Basically, ionic bonds, ionic compounds, they will always have a metal and a non-metal. Always. But that means that you would need to be familiar with the periodic table and know which elements are metals and which ones are non-metals. Okay. Now, technically, what's going to happen in the ionic bond is that the metal is going to lose electrons, and then the non-metal is going to gain electrons. And so when the metal loses its valence electrons and it just says, you know what, just forget it. I'm never going to get to 8 valence electrons, so here, just somebody take them. The non-metal will gain them and accept them and become the negatively charged anion. Well, when that happens, then that means that they're going to become attracted to each other through opposite charges. So that technically is how the ionic bond forms. Is through the attraction between the opposite charge. Oh yeah, between the opposite charges. Okay, now let's take a look at covalent bonding. So with covalent bonding, covalent bonds are always going to involve a sharing of electrons. Now, the way that you can recognize a covalent bond is that for a covalent bond, it's always going to be between two nonmetals. Always. It will always be between two nonmetals. Okay. Now the sharing between the nonmetals can be equal or unequal. Yeah, it can be equal or unequal. Okay, so if it's equal sharing between the nonmetals, then that's called nonpolar. And then if it's unequal sharing between the two nonmetals, then that's called polar. Okay, so then you might be wondering, okay, but how are we going to figure out if it's polar or not? Okay, so whether a molecule is polar or not is really going to depend on the electronegativity of the atom. It's like, what? What is electronegativity? So, electronegativity is kind of like the greediness or the selfishness of the atom. The desire for the atom to try to pull more electrons closer to it. So it's like, I want them closer to me. I want them to spend more time with me. That's what an electronegative element is basically saying. Spend more time with me. Now, you might be wondering, how are we supposed to figure out the electronegativity of the atom? How do we know if it's electronegative or not? That is something that you can predict from the periodic table. You can predict it from the periodic table. So, electronegativity is supposed to increase going up and to the right. And so the most electronegative element is supposed to be fluorine. Fluorine is the most electronegative element. Now, the reason why is it not helium? Why is helium not the most electronegative? Because remember, helium already has 8 valence electrons. It's not interested in pulling more electrons. It already has 8 valence electrons. Its octet rule is already fulfilled. Done. So it's really not interested in pulling electrons closer to it. So, right, the most electronegative element is going to be fluorine. And then all of the elements that are right next to fluorine are also extremely electronegative. Highly, highly, highly electronegative. So, for example, like oxygen, chlorine, bromine, nitrogen, kind of sulfur, kind of, but yeah. All of the ones that are right next to fluorine are extremely electronegative. Okay. Okay, so what you have to do though is you have to compare the electronegativity. It's not enough to just go, "Oh, it has an electronegative element. It's polar." No, you cannot do that. The reason why is because you should think about it more like a tug of war between the two elements. You need to compare the strengths of both elements before you can figure out who wins, right? I mean, just because you know that one person in the tug of war is strong, so what? What's the strength of the other person? Are they also strong or are they weak? You need to know the strengths of both people before you can figure out if it's polar or not. So the strength, like the electronegativity of both elements. So, I mean, where's the notes? Okay. So let's say that we're looking, for example, at a bond between carbon and oxygen. So carbon is not that strong, not that strongly electronegative. But oxygen is extremely electronegative, highly, highly electronegative. Okay, so basically it's like one weak person in the tug of war and then one strong person in the tug of war. So that's what makes it polar, is because there's one strong and one weak. So that's what makes it polar. Okay, now let's say that we're actually looking at, how can we say? Let's say we're looking at a bond between a carbon and a hydrogen. Okay, so carbon is not that electronegative, but neither is hydrogen. Hydrogen is also not that electronegative. So it's like two weak people in a tug of war. When you have two weak people in a tug of war, nobody's going to win that. Nobody's going to be able to pull the electrons closer to it. Okay. And then let's say that we have two strong. What happens if we have two strong electronegative elements? So for example, let's take a look at two chlorines. Okay, well, both of the chlorines are going to be very, very, very strong because both of them are right underneath fluorine. They're right underneath fluorine. Okay, but they're both equally strong though. So because they're both equally strong, even though they're both very, very, very strong, because they're equally strong, nobody wins. Like if you have two equally strong people in a tug of war, again, nobody wins that. Nobody's going to be able to pull the electrons closer to them. Okay. So that's how you figure out the polarity of the bond. Okay. Now, let's actually go over a couple questions. I think I forgot to go over this earlier. Let's go over some example questions of what to do if a question is asking you to find like the total number of electrons. Okay, so let's say a question saying how many electrons are in a, well, let me bring a periodic table. Okay, let's say a nitrogen ion. First of all, as soon as you see the word ion, you need to know that the electrons, or well, how about we say the final answer will not equal the number of protons. Normally, the electrons automatically do equal the number of protons, but that's for an atom, not an ion. In an ion, they've lost or gained electrons, so now it's different. Okay, and then okay, I lost my train of thought. All right, but yeah, you know that you have an ion. So first you need to find the original number of electrons. And how do we do that? That's just through the atomic number. Because the atomic number equals the protons, and the protons equal the electrons of the atom, the original atom. So for nitrogen, nitrogen's atomic number is 7. So that means that the original atom had 7 protons and it started off with 7 electrons. It started off that way, at least. Okay, now The next thing that we need to do is we need to find the number of valence electrons. And how can we do that? We can do that through the group number on the periodic table. We can do that through the group number on the periodic table. Okay, so nitrogen is in group 15. Everyone in group 15 has 5 valence electrons. We need to figure out if the atom is going to lose or gain to get to 8, and how many will it lose or gain. So nitrogen has 5 valence electrons. That's pretty close to the goal of 8. So I would assume that nitrogen is going to want to gain valence electrons. And actually, to get to 8 valence electrons, nitrogen would have to gain 3 valence electrons. Well, losing is subtracting, gaining is adding. So nitrogen started with 7 electrons. When it's an ion, it gains 3 more. So 7 plus 3 is 10. That means that the nitrogen ion has 10 electrons. Okay, does that make sense?
Yes, ma'am.
Okay. And then let me see. Okay, let's do one last example before we have to stop. Let's say it says how many electrons are in, and then let's say that it gives us an ion with the charge. Hold on, let me pick one because I want to prove a specific point. Let's say we have Mg with a 2 plus charge. And it says, okay, how many electrons are in that ion? 2 plus. Duh. Okay, so we have an ion. How do we know that? Whenever there's a number in the upper right corner with a plus or minus sign, that is a charge right there. And only ions have a charge. If there's a charge in the upper right corner, that's an ion. That's how we know that that's an ion. And again, the final answer will not equal the number of protons. Now, we still need to find the original number of electrons. That's the same. How? So the atomic number is protons. Protons equals the electrons of the atom. So magnesium's atomic number is 10. That means it has 10 protons, and it started with 10 electrons. Now, when they give you the charge, that actually makes your life 10 times easier. Like way, way easier. Because what we're going to do is we're going to use the charge. How can we say? If it's positively charged, then that means that it lost electrons. Positively charged. And then if it's negatively charged, then that means that it gained electrons. And then the number in the charge actually tells us how many electrons were lost or gained. Makes it so easy. So because magnesium's charge is 2 plus, that means that it lost 2 electrons. And again, losing is subtracting, gaining is adding. So magnesium started with 10. Oh, I'm sorry. Magnesium did not start with 10. Magnesium starts with 12. My bad. Magnesium's atomic number is 12. Magnesium started with 12 electrons. When it's an ion, it loses 2 electrons. So 12 minus 2 is 10. So I also want you to notice that for both nitrogen and magnesium, when they became ions, they both ended with 10 electrons. When that happens, when 2 atoms have the same number of electrons when they're ions, we call this isoelectric. When 2 ions have the same number of electrons,